Hello everyone. Today we are going to be looking at lesson 4.7, which is about imaginary solutions. So I've been kind of leading you up to this lesson quite a bit. As we have talked through quadratics, we've said, well, at this point we would have to stop because there's no real solution, but we will at some point later in the semester learn about the imaginary solution. So here we are. Today is the lucky day to learn about the imaginary solution. When we talked about quadratics a long time ago and we talked about solving by graphing, we said if it touches the x-axis twice, then it's going to have two solutions, here and here at the two x-intercepts. And we said sometimes the parabola comes down and touches the x-axis once right at the vertex, and that time that has one solution. But then we also said there are times when the parabola never touches the x-axis. So in this case, we used to say no real solutions. And that's true. It really doesn't have any real solutions. But when we have this type of context, that doesn't necessarily mean we want to stop. This might be one step in the course of a big solving problem. And we don't actually want to quit at this point. We want to keep going so that we can find out something else later on. You'll get to all of that when it gets to some of your higher level math classes. But for right now, you just need to trust me that when we have no real solution, we're going to need to continue working by using what's called imaginary solutions. So the imaginary number is just I. So it looks like any old variable, like an x or an a or any other one. It's just going to have to be an I. It's what we're going to use when we have no real number solution. So in the course of solving previously, if you had gotten to the point where you had like x minus 2 squared equals negative 64, and you would try to take the square root of each side, at this point you'd have to stop and you would say no real solution because there's no square root of a negative number. Well, the imaginary unit I is going to allow us to take the square root of negative numbers, and that's how we're going to be able to continue solving. So I, by its definition, is simply the square root of negative 1. Now, if you think about that and say, okay, well, what if I squared both sides? Well, remember, squares and square roots cancel out. So I squared is also defined as negative 1. Now, if they're going to ask you to use this on the PSAT or the SAT, they're going to remind you what I is, or they'll remind you what I squared is. So if you happen to forget, they'll usually give you a pretty good reminder in the course of your question. So here's the way it works. If you have a square root of a negative number, all that's going to happen is you're going to still take the square root of the number itself, in this case it's r, but the negative will cause an I to go in front of that radical. So if we have the square root of negative 3, then we're still going to have the square root of 3, but now we're going to have an I that comes out because of the fact that our answer is imaginary. Now, to add a little bit of complication to that, if the number that's under the square root is a perfect square, so if it's one you can actually take the square root of, then you're going to take that square root. So the square root of 25 is 5. The negative will cause an I. Now up here we said it has to go in front. Well, it goes in front of the radical sign, but it goes behind a number, just like any other variable would. We wouldn't say x5, we say 5x. So we want to make sure we use our plus or minus because we've taken a square root. The square root of 25 is 5, and because it was negative, we have to include an I. All right, the square root of negative 64. Plus or minus, because we're taking a square root, the square root of 64 is 8, and because it was negative, we'll have an I. Now here's one where we can't take the square root, so the I is going to show up in front. So the square root of 10 is not something we can take. So we're going to have still our plus or minus, and then because it was negative an I, and then the square root of 10 will remain under the radical. Let's give it a try with the square root of negative 100. This is a perfect square. So the square root of 100 is plus or minus 10, and because it was negative, it's going to be plus or minus 10 imaginary. Then I wanted to give you one that's going to break down like you had in yesterday's questions. So we have the square root of negative 200. Well, 200 is not a perfect square, but it does break down, unlike the 10 from over here. So we need to break that 200 down. So we're going to break that into negative 100 times 2. Now the square root of 100 we know to be plus or minus 10. Because it was negative, we're going to use our I. but that 2 is still trapped under the radical. So here's the way it should look. The actual square root, then the imaginary, and then something that's still under the radical. Well, let's take a look at the square root of negative 48. So we're going to have to break that down because 48 is not a perfect square. So I'm going to break that into negative 16 times 3. Notice I'm always placing the negative on the perfect square. So the square root of 16 is plus or minus 4. Because it was negative, it will be imaginary. And then the square root of 3 is still trapped under the radical. How does that work in the course of solving quadratic equations? Let's start with some of the easiest ones we did. If we just have an x squared, we know that we can get rid of a squared by taking a square root. What we do to one side, we do to the other. Squares and square roots cancel out, so we have x equals the square root of a negative 16. So 16 is plus or minus 4, and because it's negative, it will need an I. So our solutions, imaginary, are positive 4i and negative 4i. Same thing happens here. We're going to take our square root to get rid of the squared. What we do to one side, we do to the other. Squares and square roots cancel out, so we have x equals. Then we have the square root of negative 36. The square root of 36 is plus or minus 6, and because it's negative, it will have an I. So our two solutions are 6i and negative 6i. Now in letter C, we have a little bit more complication because it's not just x squared. First, we have to get rid of this plus 9 so that we can get x squared by itself. So we'll subtract 9. What we do to one side, we do to the other. X squared equals, and 0 minus 9 is negative 9. Now to get x alone, we have to get rid of the squared, so we'll square root. What we do to one side, we do to the other. Squares and square roots cancel out, so x equals the square root of negative 9. So the square root of 9 is plus or minus 3, and because it's negative, we'll include an I. So our solutions are 3i and negative 3i. If I move on to letter D, x squared is already alone, so I need to get rid of the squared, so I'll square root. What I do to one side, I do to the other. Squares and square roots cancel out, so I have x equals the square root of negative 8. 8's not a perfect square. So we're going to have to break that apart. So thinking about that perfect squares list, the biggest perfect square that will go into 8 is 4, and that's the one I'm going to make negative. So negative 4 times 2. Now the square root of negative 4. The square root of 4 is plus or minus 2. Because it's negative, it will have an I. This 2 is still trapped under the radical. So we have imaginary and radical solutions. 2i square root 2 and negative 2i square root 2. Same thing happens for letter E. We need to take the square root to get x alone. What we do to one side, we do to the other. Squares and square roots cancel out, so we have x equals the square root of negative 50. 50 is not a perfect square, so we need to break it down. Perfect square that goes into 50, the highest one, 25 times 2. Remember to make your perfect square the negative. The square root of negative 25 will be plus or minus 5 because it's negative I. And keep our 2 that's trapped under the radical. There we have our two solutions. Letter F puts together what we did in C along with what we did over here in D and E. So we need to move that 7 out of the way so the x squared is the only thing on that side. 0 minus 7 is negative 7. Now we'll need to take the square root. What we do to one side, we do to the other. Squares and square roots cancel out, so x equals the square root of negative 7. Now if I try to break that down, 7 is prime. So the only thing that goes into 7 is 1 and 7. So the square root of negative 1, that's plus or minus just I. And then we still have 7 trapped under the radical side. Let me switch pages. Now I'm not going to go through all of the examples on the second page, but I do want to make sure that you remember a little bit about completing the square as well as the quadratic formula. So what we're going to do is just begin our problem the same way we normally would, but we're going to find out at some point whether or not we have an imaginary solution. So let's look at the first one. It asks us to do this by completing the square. Completing the square means we're going to have a perfect square trinomial. There's currently no C value in there, so we're going to make a box and copy everything else down. The whole goal of a perfect square trinomial is so that we can write it as a binomial squared. X in the front. Half of 10 is 5. 5 squared is 25. That's our perfect C value. What we do to one side, though, we have to do to the other. So now we need to do negative 41 plus 25, which gives us negative 16. Now to get the x alone, we have to get it out of the parentheses, which means we need to get rid of the squared. So we'll take the square root. What we do to one side, we do to the other. Squares and square roots cancel out, so we have x plus 5 equals, and the square root of negative 16 would be plus or minus, the square root of 16 is 4 because it's negative an I. Now we still need to get x alone, so we'll subtract 5 from each side. And this is a lot like your radical solutions. This component should go first, so negative 5 plus or minus 4i. The imaginary piece goes in the back, just like the radical piece goes in the back. Let's try letter C. I'm probably just going to work straight down this one side of the page, and then I can make a separate video with the other examples if you need more. So here we have a C value. That's not the one we want, so we're going to subtract 6 on each side. So now I have x squared minus 8x. Now I can put in that perfect C value box. And negative 35 minus 6 is negative 41. Now we need to find that perfect C value. The whole point of making a perfect C value is so that we can write this as a binomial squared. So half of negative 8 is negative 4. Negative 4 squared is positive 16. But what I do to one side, I have to do to the other. So now I have negative 41 plus 16, which is negative 25. Now to get x alone, we have to get rid of the parentheses with the squared, so we'll take the square root. What we do to one side, we do to the other. Squares and square roots cancel out, so we have x minus 4. I don't even need that in parentheses anymore. Let me erase those real quickly. And then over here we have the square root of negative 25, so plus or minus. The square root of 25 is 5, and because it was negative, an I. We're almost done. X is not quite alone yet. We still need to add 4 to each side. And the appropriate way to write that is to put our regular number first and our imaginary part in the back. So 4 plus or minus 5i. And these would be our two imaginary solutions to our equation. Now the next section asks us to solve by using the quadratic formula. So maybe let's write that down just as a reminder. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to be utilizing our values and plugging into that formula. So here we have an a value of 1, a b value of negative 10, and a c value of 34. It does equal 0, which remember that has to be true before you can get started. So our formula will become x equals negative, and then a b of negative 10, plus or minus the square root of b squared minus 4 times a times c, and all of that is going to be over 2 times a. And then we simplify. X equals a negative 10 is 10 plus or minus the square root of negative 10 squared would be 100. Remember, that's always going to be positive even if it's a negative. And then we will do 4 times 1 times 34. And that's going to be negative because there's only one negative in there. So negative 136 all over 2. Now we continue working under the radical. So x equals 10 plus or minus the square root of 100 minus 36 is negative 36 all over 2. Now we have x equals 10 plus or minus, and the square root of negative 36. 36 is 6, and because it's negative, it's going to be an I. So 6i all over 2. Now each of those do divide by 2, so we're going to go ahead and divide. 10 divided by 2 is 5, plus or minus, and 6i divided by 2 will be 3i. So our solutions are 5 plus 3i and 5 minus 3i. Alright, last one that I'm going to go over in this video, but I do want to quickly mention letter D, because this one does not equal 0. You would have to subtract 12 right here before you could get started on that one. All right, let's quickly do letter C, and then I'll make a separate video with the B's and D's on the back in case you have questions on those. All right, we have an A value of 8, a B value of -4, and a C value of 5. We're going to plug into the quadratic formula. X equals negative, a B value of -4, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. And we simplify. A -4 is 4, plus or minus the square root of -4 squared is positive 16, and then -4 times 8 times 5, so negative, I'm thinking I know that, but I want to just double check it in my calculator so I don't tell you guys wrong, of 160 all over 16. So now we have x equals 4 plus or minus the square root of, and now we want to do 16 minus 160, which is -144, divided by 16. Continuing to work, we have 4 plus or minus, now the square root of 144 is 12. Because it's negative, it's going to have an I, so 12i all over 16. And then, like we discussed yesterday, this doesn't divide by 16, but they do all simplify. They all have a common factor of 4. So we would be dividing each of those pieces by 4. 1 plus or minus, and then 12 divided by 4 would be 3 with our I, and 16 divided by 4 is 4. So there we have our two imaginary solutions. All right, if you're still needing some more help, then feel free to watch the other video with the B's and the D's. If you don't need any more help, go ahead and start the assignment. I'll see you later.